STAAD Foundation Advanced is not a typical spreadsheet-based design application. It is a comprehensive solution that assists users in laying the groundwork for their entire project. It has tools like the general arrangement graphic to help you choose the right foundation type. It can run through hundreds of different load combinations to find the most efficient foundations. Construction-ready detailed drawing and true calculation sheet that generates step-by-step calculation with applicable equations, code clauses, and intermediate values are included in the output. The drawings are given to ensure the design conventions are correctly explained and understood.
Once we launch the STAAD Foundation Advanced, we will see these three modes of operation. Those are the general mode, the plant mode, and the toolkit mode. When creating your project, you'll choose one of these modes. For the general mode, it is an open modeling of common foundation types. For the plant mode, it is for vertical and horizontal vessels and mechanically anchored tanks. And lastly, for the toolkit mode, it is a wizard-based mode for quick and easy data input for simple foundation types. For this demonstration, we will go for the general mode. But before we begin designing our foundation, make sure that the units are consistent. To set up the units, click the Setup Units in Settings group at the Home ribbon tab. You can choose the units that is appropriate to your project, whether it is SI or English units. You must also have the physical information of your project, such as the column locations, the loadings, etc. Or you can import an existing STAAD file. STAAD Foundation Advanced will introduce you to multi-pane window environment. The leftmost pane is called the main navigator. The middle pane is called the main view, which has multiple tabs for graphical display, layout drawing, detail drawing, and calculation sheet. The rightmost pane is called the data area, and the bottom pane, which is called the output area. The STAAD Foundation Advanced is a 3D modeling environment. Foundation positions are defined in Cartesian coordinates where y-axis is vertically up and the axis system follows right-hand rule as shown in the main view.
Data in STAAD Foundation Advanced can broadly be categorized as global and local data, which can be seen at the left side. Global data are grouped in three main categories, which are foundation plan, load and factors, and soil properties. All the groups are important, but foundation plan and load and factors are essential for setting up the foundation analysis design environment. On the other hand, local data are specific to foundation types.
If you only have physical information of your project, it is recommended that you begin by laying out column positions. The column position is under the foundation plan. So to give you an example, I made a plan to better understand the process without having to import a STAAD file. This table allows you to import your supports coordinate. Next is to set the proper dimensions of columns. The dimensions of columns will be used for shear and crack moment checks.
Take note that if a column is connected to a pedestal, column dimension won't be used for any design check. So you can ignore column dimension if you were to design foundation with pedestal.
After the layout, we will go on to the next step, which is creating a new load case. Keep in mind that each load situation is assigned to a specific load type. You can see all the options by looking at the loading type drop-down menu. Then you can choose between primary, service, and ultimate load as the load case type. Service loads are used to design the footings dimension, and ultimate loads are used to design the concrete reinforcement and footing thickness. Selecting primary will allow the load to be used for both cases. Enter also the load title to give each load case a descriptive name to help identify each load cases. Then, you can now add when you're done. You can create as many primary load cases relevant to your foundation. Select the primary load case and right-click, then add column reaction. Note that negative and positive values follow the sign conventions of the axis system. Negative values are downward compressive forces, and positive values are upward tensile forces. Input all the external load forces presented in your project. Then you can now assign the loads. The assigned loads will be displayed on each footings as illustrated in the main view.
The primary loads added are acting on the foundation separately. Therefore, these loads must be combined using load combinations specified in structural code.
Load combinations can either be created manually or by using load combination generation tool. I will use generate load combination because it's faster. Generate load combination automatically generates all the possible service and ultimate load combination using the appropriate factors to satisfy the tool. If you wish to add the load combination of NSCP, you can select user-defined and input all the factors specified in NSCP's load combination. We can now generate load for the service and ultimate load by just clicking these buttons. The generated load combination are now shown under the loads and factors in the data area. For the next step, go to Job Setup and create a new job. The job must be set to design any footing. I will create an isolated foundation and name it Isolated Footings. It is your choice what job title you want to put here. For the job type, select what footing type you are designing. For the design code, we will use the US code. And for the default unit type, it's up to you which units you wish to appear in the results. And lastly, the selected load cases must be chosen. Exclude the primary load cases because only the load combinations should be used for design purposes. You can now click Create Job.
STAAD Foundation Advanced will individually apply each load combination to foundation and design, each support according to its limiting load combination. The purpose is to provide optimum footing design.
In the main navigator, a new set of commands will be generated once the job is created. Each of these commands will require extra information known as design parameters. Remember that the STAAD Foundation defaults all design parameters inputted data, and you can change all of these data. You can enter the needed data if your project has a soil report. In my case, I assume that the soil is a cohesive soil, which means it's a type of clay. And if you choose cohesionless soil, meaning it's a type of sand. The data I provided are all based on assumptions. You'll need to check the soil report for accurate information. For the footing geometry, you can choose the maximum and minimum dimensions of your footing so that the STAAD Foundation can properly design it. We can now design the footing after setting up the parameters. During the design, the program will select a certain strength load as the critical load case. The output pane will display a series of messages as the program performs the footing design. If nothing goes wrong in your project, the STAAD Foundation Advanced will provide you a detailed result in an XMS file. It will also provide you with detailed and scheduled drawings, as well as the general arrangement drawing or GA drawing, all of which can be saved as AutoCAD drawings, or you can choose which file type you want to save. The calculation sheet can also be printed for real-time checking.